Hi, everybody. I'm Greg Fishel, and welcome to bonus weather video number 1 for this week. And we're going to talk today a little bit about why the hottest temperatures of the summer typically do not occur on the longest day, and the coldest temperatures of the winter do not occur on the shortest day. Okay? And it's the same principle really on a daily scale as well. Like you might think, why isn't the hottest temperature at noontime? Why does it usually occur around 3 or 4 or 5 o'clock? So that's what we're going to try to attempt to explain here. And so here I have the ground in green and the sky in blue. And as many of you know, the sun delivers ultraviolet radiation to the Earth. The Earth then absorbs that ultraviolet radiation and re-emits in the infrared part of the spectrum. And that is a much longer wavelength, if that makes any sense to you at all. So let's go to June 21st. This is, the first day of summer, give or take a day. And this is when the sun's incoming radiation is at its peak. I'm going to use a bathtub, and I know it's a terrible representation of a bathtub. I told you many times I'm a terrible artist, and I had to combine various shapes in PowerPoint to try to get this to look like any reasonable facsimile of a bathtub, all right? So the water level is obviously quite high in the summertime. I'm going to let the faucet represent the strength of the sun, how much incoming radiation there is, and the drain, I'm going to have that represent the Earth in terms of outgoing radiation, okay? So on June 21st, that raindrop is at its peak, or that drop. So in other words, there's more incoming radiation from the sun on June 21st than there is any other day of the year. And the reason it continues to get warmer after that is that even though the amount of radiation from the sun is decreasing a little bit, there's still more coming in than there is going out. And so usually, if you look at a 30-year average, the peak average temperature occurs in the middle of July. So let's move things along to about July 15th. And at this point in time, the bathtub water level is at its peak, and the raindrops are of equal size, or the water drops. And so there's as much coming in as there is going out, and so there's a balance there, and the water level peaks. Now, we go to September 21st, on or about the first day of fall, and at this particular point in time, the water level has come down, as you might expect, and that water level represents the temperature of the atmosphere. And so now there's definitely more leaving than there is coming in, and so you would expect that water level to decrease. And then by the time we get to December 21st, the day where the sun is at its weakest and the days are the shortest, there is definitely, again, more going out than there is coming in, and so the water level continues to descend. But does it start going up right after that? No, for the same reason that we just talked about why the hottest temperatures of the summer occur after June 21st on average, because it takes until January 15th for the amount coming in to equal the amount going out. And so temperatures typically continue to get colder into the month of January, and then after January 15th, then the surplus begins to accumulate. In other words, more coming in than there is going out, and so the bathtub level starts to rise once again. I hope that made a little bit of sense despite the pitiful graphics, and I hope it was a better explanation than the graphics. All right, so that's it for today. Bonus weather video number 1 for the week. We'll have another one coming up on Friday, and of course the normal daily weather update coming up tomorrow. Y'all take care, and we'll talk soon.